On October 11, 2023, Chinese scientists announced successfully constructed the quantum computing prototype Jiuzhang 3. Another significant step has been taken on the road to developing quantum computers. The Jiuzhang 3 speed in solving Gaussian boson sampling mathematical problems. It is faster than the current fastest supercomputer in the world by a factor of 10 billion trillion. In short, a quantum computer is a type of computers that utilizes principles of quantum mechanics. It can execute certain specific calculations more efficiently than conventional computers. A quantum computer is a computer, but it's not simply an advanced version of a computer. Quantum computers utilize physical systems such as atoms, ions, photons, and others. Different types of quantum computers use different particles. This Jiuzhang employs photons. Quantum computers store more information per unit. Quantum computers use qubits to store information. Each qubit can be set not only to 1 or 0, it can also be set to both 1 and 0. Traditional computers can only set 1 bit to 0 or 1. Quantum computers can thus simultaneously carry more content. Regular computer units can only process 1 bit at a time. Quantum computers, on the other hand, can process 1 quantum bit at a time, thereby greatly increasing processing speed. In the fields of computer science, IT, and mathematics, the computational power for a specific problem far exceeds that of the current most powerful traditional computers. Furthermore, it can also be achieved through quantum computing, establishing quantum communication networks and quantum internet, among others. In terms of practicality, quantum computers have a wide range of applications and potential, such as cryptography cracking, big data optimization, material design, etc. At the same time, the development of quantum computers will empower artificial intelligence, thus reducing errors in AI applications and creating intelligent systems that allow for early diagnosis of problems. It's worth mentioning that it is also closely related to drug development, with such powerful computational capabilities could potentially increase the efficiency of early-stage drug molecule screening to over 90%. Costs are also significantly reduced. Furthermore, the rapid computation of quantum computers also has common yet widespread applications. For example, route planning, helping AI in cars calculate the most efficient route. After watching the video, everyone should have a better understanding